Hi everyone, today we'll be covering how to balance chemical equations. Now let's take a look at some rules that govern chemical equations. There are two rules that govern chemical equations. These are the conservation of mass and the conservation of charge. Look at the conservation of mass. It means that on both sides of the equation, the number of the same elements must be constant. For example, let's take a look at this equation between dilute sulfuric acid and magnesium metal in an acid-metal reaction to form a salt. In this case is magnesium sulfate and hydrogen gas. On each side of the equation, there are two hydrogen atoms, one sulfur atom, four oxygen atoms, and one magnesium atom. Let's take a look at conservation of charge. It means that the net charge on both sides must be equal. For example, here's the net ionic equation representing a neutralization reaction. It means that all ions are shown in aqueous solution and that all spectator ions are not included in the reaction. So, for this instance, we can see that the net charge on the left side and the right side are the same and they are equal to 0. Let's practice. We'll try balancing some incorrect chemical equations together. Or are they incorrect? Anyways, here are the reactions that we'll be covering in this video. Now let's take a look at the first reaction. We first check if the reaction has the correct reactants and products. It happens that this reaction has the correct reactants and products for the displacement reaction between aluminum and iron 3 oxide. Aluminum metal is being oxidized while iron and iron 3 oxide is reduced to iron metal. This reaction is also known as the thermite reaction. Since reduction and oxidation occurs in the same reaction, this is called a redox reaction, a mixing of the words reduction and oxidation. Now let's check for conservation of mass. We will realize that mass is not conserved. On the left side of the equation, we have one aluminum atom, while on the right, we have two aluminum atoms. On the left, we have two iron atoms, while on the right, we have one iron atom. Let's fix that. Much better. Now let's check for conservation of charge. We will find that charge is conserved. Since all reactants and products are not ions, they are neutral and have zero charge. Both the right and left sides of the equation have the same net charge of 0. This equation is now balanced. Now try it for yourself on the dissociation of aqueous ammonia. Pause the video here if you need time to work it out on your own. Okay, now let's move on. First check if the reaction has the correct reactants and products. It happens to be that this equation has the correct reactants and products for the dissociation of aqueous ammonia. This is a reversible arrow. That means the reaction does not proceed to completion. A significant amount of reactants remain. There is an equilibrium established. Now let's check for the conservation of mass. We will realize that mass is not conserved. On the left-hand side, there are 5 hydrogen atoms, while on the right, there are 9 hydrogen atoms. On the left, there is 1 nitrogen atom, while on the right, there are 2 nitrogen atoms. Let's fix that. better. Now let's check for conservation of charge. We will find that charge is conserved. So, on the left and right sides, the net charge is equal to 0. The net charge on both sides are the same. The equation is now balanced. We have come to cover the last equation we're covering in this video. This is redox reaction between potassium manganate 7 and sodium thiosulfate. This is a special form of chemical equation called a net ionic equation. We have covered what is a net ionic equation earlier in the video. Ions that do not participate in the reaction, such as potassium and sodium ions, are not included in the equation. They are known as spectator ions. Luckily for us, this equation is already balanced. Don't believe me? Check it out for yourself. Thank you for watching, and I wish you a good day ahead.